If you were to put the suspension system of the ordinary car you drove today under the BelAZ 75710, the world's largest truck, that suspension would turn into metal dust in a fraction of a second. This colossal monster carries rocks equivalent to the weight of 2 fully loaded passenger planes every single day. It navigates mining roads filled with jagged rocks and massive craters. It is an indispensable part of mega construction and mining sites. How is it possible to withstand such weight, let alone carry it over rugged dirt roads? How do the suspensions that keep a truck carrying a 450-ton rock upright actually work? You won't really see these giant trucks on the streets. When we say truck, the semis we see on the highways come to mind. Forget about those. The BelAZ 75710 we're talking about reaches a total weight of 810 tons when fully loaded. Yes, 810 tons. Let's make it easier to understand with some simple numbers. This is the weight of 500 cars stacked on top of each other. Or imagine stacking exactly 5 blue whales, the largest animals on Earth. Just a single tire weighs more than 5 tons and is 4 meters tall. All vehicles have a suspension system. You might think it's just there for comfort. However, it's a component with many duties, like providing traction and enabling cornering. But the suspension system on this giant truck has far greater responsibilities. While something of this weight even moving is a miracle in itself, this truck isn't driving on smooth asphalt. It's constantly going in and out of crater-like potholes. Think about this. You know that shock you feel in your knee when you stomp your foot hard on the ground while walking down the street, right? Now imagine an 810-ton version of that shock. If that shock weren't absorbed, the truck's steel body would shatter into pieces within seconds. The driver's cabin would be thrown off, and the tires would explode like bombs. When engineers first started designing these behemoths, they dealt with many issues like power and durability. But one of the most exhausting challenges was keeping the vehicle standing. They started by using the coiled steel springs or leaf springs we see on normal cars or trains. They figured, as the truck gets bigger, we'll just make the spring bigger. Sounds logical. But it didn't work out that way. No matter how thick they made the steel springs, under an 810-ton load, the steel would crystallize and shatter within seconds. Steel had reached its limits and given up. Things had to change. They knocked on the door of aviation technology. They looked at how the tires of airplanes hitting the ground at 250 miles per hour absorbed that massive impact. And instead of steel, they decided to rely on 2 things that never break: liquid and gas. To explain this complex system simply, imagine giant syringes. In engineering terms, it's called a hydropneumatic suspension, but we'll call it the battle between liquid and gas. Picture this. There are massive steel cylinders at all 4 corners of the truck. The bottom half of this cylinder is filled with a special hydraulic oil. The top half is filled with highly pressurized, compressed nitrogen gas. And between them is a piston that can move freely. Remember those elementary school science experiments? The ones showing that gases can be compressed but liquids cannot. The kid in the back row definitely asked, "Where are we ever going to use this in real life?" Well, this exact knowledge is what allows an 810-ton weight to glide like a swan over ruined roads. When the truck rolls over a giant rock or falls into a pothole and climbs back out, the wheel is violently pushed upwards. The piston shoots up and forces the hydraulic oil upward. The oil, taking the initial impact, moves up like a wall and mercilessly crushes the nitrogen gas above it. This is where the gas works its magic. It doesn't break like a steel spring. It compresses, shrinks, absorbs the impact like a perfect cushion, and then slowly pushes the oil back down. No steel, no springs. Just the elements of nature, utilizing their physical properties. Of course, just adding some nitrogen gas to the suspension system doesn't create a miracle on its own. On the contrary, it turns it into a ticking time bomb. But here is where the interesting part begins. If this system only worked like that, things would end in a terrible disaster. After the gas compresses, it has to return to its original state. If the gas abruptly pushed the oil back with no resistance, that 810 tons of energy would launch the truck into the air and flip it over as if it were on a giant trampoline. That absorbed energy had to go somewhere. It had to be destroyed. So, where does that energy go? As the oil moves inside the cylinder, there are tiny holes it must pass through. These holes are as small as a pen tip. The oil, squeezed by 800 tons of pressure, encounters immense resistance as it forces its way through these orifices. This drops the oil's pressure but generates an incredible amount of heat. In other words, the unwanted kinetic energy is converted into heat energy and dissipated outward through the metal body. Now, instead of bouncing, the truck practically sticks to the road like chewing gum. That massive impact energy is literally annihilated by being converted into a temperature rise of just a few degrees. This giant truck, which gets loaded with about 100 tons of rock in a single drop, can only survive with such a cleverly designed suspension system. It's almost like dropping a passenger plane on top of another passenger plane. The suspensions on the four corners of the truck share the violence. The nitrogen gas instantly compresses by millimeters. The oil screams through the narrow valves, and heat radiates. The system absorbs this massive shock so flawlessly that when 100 tons of rock crash into the bed, the operator in the cab only feels a tiny tremor in their coffee. By the way, if these kinds of mind-boggling engineering secrets catch your interest, you can join our channel by hitting the subscribe button. Trust me, doing that is way easier than moving that colossal truck. We focused on the suspensions in this video, but there is another hidden hero here. The truck's enormous tires take on the task of dampening 30% of the impact. Otherwise, it would be impossible to carry this load with hydropneumatic suspensions alone. Each of these tires, weighing over 5 tons and standing 4 meters tall, has hundreds of kilometers of steel wire woven inside. While a normal car tire has about 30 psi of pressure, the pressure in these giant tires is at unbelievable levels. How much do you think these suspensions, battling against an 810-ton weight, actually weigh? Just one suspension weighs as much as a small hatchback car. 1 ton. Also, when there's an issue with the truck's massive suspensions, special cranes are required to lift the truck. It's impossible to do it with a simple jack. Ultimately, the secret keeping the world's largest dump truck upright isn't thicker metals, harder steels, or impenetrable armor. On the contrary, it's flexibility. It is the invisible dance of oil and gas silently battling each other inside a steel cylinder, completely unseen from the outside. Human ingenuity abandoned brittle solids and gracefully solved the world's heaviest problem by utilizing the unbending physical laws of liquids and gases. Different technologies are used in giant vehicles like the BelAZ 75710. This is because these vehicles can face highly unpredictable situations. As you can see, an entire video is needed just to explain the suspension system. Despite their grueling tasks, engineers always manage to find a way to overcome the challenges. Keeping the BelAZ upright was an engineering marvel. But what about the machine that loads tons of rock into this giant truck? Why doesn't the Caterpillar 6090, one of the world's largest excavators, tip over when dumping that terrifying weight of dirt into the truck? The answer lies not in how the bucket dumps, but in the hidden trapdoor beneath the bucket. Click on the video you see on the screen, and I'll see you there to explore the bizarre engineering behind the world's most dangerous dumping operation.